Welcome to your new alcohol detector. Today, I'm going to be showing you how to calibrate your device. Step 1 is to turn on your machine and let it warm up for 15 minutes. In the meantime, you can make sure you have all of your samples prepared. To learn how to prepare your samples yourself, you can visit this video up here, or you can use the standards that are supplied to you in the box. If for whatever reason you turn off your device during the warm-up period and have to turn it back on, you can always skip the warm-up by pressing and holding the silver button to the left of the display. The warm-up period is essential for the device to work accurately. Realistically, you aren't just building a calibration curve for no reason. You want to measure some samples. Here, I have some tepache that I brewed a while ago. In order to build the calibration curve, you'll need the alcohol detector calibration document that I can provide you with. Whether or not you've purchased a detector or not, I can send it your way. You can see a screenshot of the alcohol detector calibration document here. It's really simple to use. You don't have to be an Excel wizard. You just have to enter in a few numbers. As we measure our alcohol content standards, we'll enter our values in the blue column corresponding to each of the alcohol percentages. After we enter in all of our known alcohol content standards and their raw readings in the blue column, we should have a smooth calibration curve generated in the graph on the right. On the graph, there's a y equals section. That's the equation of best fit for that line, and an r squared section. If that r squared value is greater than 0.9, then your graph is pretty good, and it should be pretty visible by the curve going through most of the data points. The y equals section will be used to fill in the coefficients box at the top of the Excel file. The number before the x is the coefficient, and the number above the x is the exponent. You can enter these numbers directly as they appear on the graph with the capital E and the negative all included. Once you've entered in the coefficient and the exponent at the top of the document, you can then use the calculator at the bottom to determine how much alcohol is in your samples. Another important thing to note when using this device is that all of your calibration standards and all of your samples must be at the same temperature. When I say that, I mean plus or minus about 1 degree Celsius or plus or minus about 2 degrees Fahrenheit would be most accurate. If you read a sample at a higher temperature, you'll get a higher reading. If you read a sample at a lower temperature, you'll get a lower reading. So with that being said, I think it's a good idea to open this away from the computer and get it up to room temperature. Oh, not very carbonated. Smells good. So we'll take one of these sample tubes and pour in a bit of our sample up to about the 25 milliliter line. The volume of your sample doesn't matter too much as long as it's between the 20 and the 30 milliliter line. Now, with these real world samples, sometimes there will be foaming that occurs in the sample. The alcohol detector is going to blow air into the sample, so any foaming that might happen could be really harmful to the device. If foam bubbles up into the detector, it could ruin the sensor inside. So I highly recommend that you add just a single drop of any neutral oil, like a vegetable oil or an olive oil, or even an anti-foam product if you have that laying around. Just a single drop will make sure no foaming occurs in the detector. Now, finally, back to the calibration. If you live in the US, I will ship out these alcohol standards to get you started. If you live outside of the US, it's a little bit tricky to ship these vials of low alcohol content liquid. And so what you'll need to do is prepare your own alcohol standards. Even if you do live in the US, you'll have to prepare your own alcohol standards. And the way I recommend doing this is in 500 milliliter or in 1 liter increments to get the most precise measurements. This glass pipette is included to make your measurements easier and more accurate. And if you want to learn more about how to make your calibration standards, I've made a separate video here. All right, so here are all of my alcohol standards here. I recommend storing these in the refrigerator just in case something grows in them, but bring them back up to room temperature before you use them. So the detector is warmed up now. You should hear a quiet buzzing from the air pump on the inside. I've already told you how to do your calibration. Now I'm gonna actually do it. So here's the first sample, 0.1% alcohol content. We'll pour in about 25 milliliters Again, the volume doesn't have to be perfect. We can screw it into our device, and you can see the reading on the left should rapidly climb, and the reading on the right should climb as well. So the reading on the left is the current raw reading of the device. The reading on the right is sort of a ratcheting mechanism to record the highest reading on the device within a given period of time. To reset the reading on the right, you can press and hold the silver button. So the very first reading is going to take a little bit more time, maybe closer to 1.5 minutes or 2 minutes, but all of the other samples should take about 30 seconds to a minute to get their readings. I also recommend doing all of the samples in duplicate, meaning you measure the 0.1, the 0.25, and so on, all the way to the 2%, and then you go back and you measure the 0.1, 0.25, all the way up to 2% again. And with having 2 data points for each alcohol content, you should get much more accurate alcohol readings. So when you're measuring a sample, what will happen is the alcohol readings will rise very rapidly at first. They'll sort of reach a plateau, and then they'll very, very slowly start falling back down again. The reading on the right is useful because it sort of records where that top of that plateau will be. The fact that the readings fall a little bit towards the end is also significant because this means that you shouldn't ever measure any sample more than once. So once you pour it in a tube and you screw it into the device and you get the reading for that, you should throw that sample away. And if you want to measure it again, you can pour from the original bottle. So you can see now the reading on the right is higher than the reading on the left, and that means it sort of reached that plateau and it started to fall back down again. So we're looking at a reading of about 574, so I'll now enter that into our graph. So now we can take this sample out and throw it away. I mean, it's alcohol and water. We'll water the yard with these samples. So now the readings on the left of the detector should very rapidly fall down, and the reading on the right should stay the same. It takes about 30 seconds to a minute for the readings to fall back down to sort of a baseline level, and once that happens, you can press and hold the silver button to reset. So what do I mean when I say baseline? Well, I would approximate this as somewhere significantly below whatever reading you get for 0.1%. So we got a reading of 574 for the 0.1% sample. And so I would say a baseline for this calibration curve would be in the ballpark of 400. So anytime the detector falls below 400, then we've reached our new baseline. And that means we can measure a new sample. So here is our 0.25%. I'll pour in about 25 milliliters again, screw it into the device, and you can watch as the readings climb. So this is a higher alcohol content, so we should get a higher reading. Now's a good time to also record the temperature that you're running your calibration curve at. This temperature will be your calibration temperature, and it will be the temperature that you measure all of your samples at. There may be some day-to-day fluctuations of your calibration temperature, but this temperature should be a target for measuring any samples in the future. So the readings seem pretty stable at about 690, so I'm going to enter that value into the Excel document in the position of the 0.25% alcohol percentage. I've also recorded the calibration temperature as about 23 degrees Celsius. All right, so we can take out this sample. Again, we don't reuse these samples, and I'll pour in the next 0.5% sample. The readings have fallen a significant amount, so I can press and hold the reset button on the left of the display. Now we can measure our 0.5% alcohol standard. So now I'm going to measure the rest of the standards and then go back through and measure again, enter them all into the Excel document that I explained previously, and then we can look at the calibration curve and see how we did. Okay, so we've built our calibration curve, which you can see right here, and the curve looks really smooth. Our R-squared value is 0.99 something. That's very good. We've entered in our coefficient and exponent at the top of the graph, and you can see our prediction column to the right of the blue column is pretty close to the actual percentage. There's going to be some variation here. There's also going to be some variation in the blue column, and this is just completely normal. You know, we measure 10 total samples in this calibration curve so that any fluctuation in the temperature or in how you measure it can all sort of even out. So let's do the exciting bit. I've got some tepache here that I want to measure. So I'm going to screw it into the device. I've made sure that it's pretty close to the calibration temperature of 23 degrees Celsius. And we'll let that run for a second. So you can see the temperature looks pretty good and the reading is still climbing. All right, so the reading looks pretty good at 748. So let's enter in that number into our calculator at the bottom of our Excel document. And that gives us a calculated alcohol percentage of 0.44%. Not too bad. Now, when you're done with the device for the day, you can screw in a sample of water just for a second to flush out some of the air in the device and to sort of rinse off the temperature probe and the tube coming out of the detector. And then once the readings settle down pretty low, you can turn it off and store it in a cool, dry place until the next time you want to use it. I hope this video has been helpful. If you have any questions, please email me at the email in the description below, or you can visit the website rarecombinations.com, or you can leave a comment below in this video. All right, the detector is done for the day, so I'll see you in the next one. Bye.